Hey guys, what's going on? Cameron here with the Lawn Care Life in Missouri. I appreciate you stopping by the channel. If you're new to the channel, hey, thanks a lot. Hit that like button if you enjoyed the videos. If you want to see more content, be sure to hit that subscribe button so you'll be notified when future videos come out. If you're returning to the channel and you've been here before, you guys know me. You guys know what the channel is all about. I appreciate the continued support, but enough talking, man. Let's dive right in to today's video. All right, guys, I am here at Wright Headquarters. Let's go in here and see if we can find the man. Hey Shuby, good to see you. Sorry I missed you at GIE.
So this is our engineering department. All of our mowers are designed in 3 dimensions and allows us to fit, parts and tolerances and everything goes together. In the computer, we typically work on a cycle where we do all the CAD work and then we go to production. Production departments support making the pieces, and then we build them together at our R&D lab. We field test for a couple weeks, functional testing at first, not as much durability testing early on. When everything's starting to work, then we start doing field testing. But we run that design, build, test cycle bunch of times before we go into production with something. We try to begin field testing as early as we can because you really want to find your problems early on before you're committed to certain components and that kind of stuff later in the process. But this is where it happens. So this is our prototype shop. We build different, test parts, test bench type stuff. We have an interesting vehicle in here. This is our robotic machine. So it's a stock ZK, but there's a few things that are different on it. You'll see it has black duct covers, has a bigger battery, has a 40 horsepower engine instead of a 37 horsepower engine. It's the same engine block, but it's digitally controlled. It works better along with the robotics. We've got cameras up here. Our earlier machines had the camera down low. We've changed the design a little bit, but we've got depth sets of cameras up here, keeping an eye on stuff. We've got the computer going off the side here in the back. You can see the drive-by-wire system. So there's another camera facing back here. These hand controls are drive-by-wire, and when you switch into the auto mode, then the robot can take control over the drive-by-wire system. But it's pretty neat. It's progressing well. This is now a serialized production unit, so we're at that phase of it. And it's really about working through the process of accelerating production and sourcing components and that kind of thing. So yeah, this is where our prototypes are built. So this is our main aisle, where on this side of the aisle everything is piece parts. On this side of the aisle everything's a serialized mower. It travels as a kit. And so right here is where it actually becomes a mower. That's the manifest. It says what type of machine it is. It has the serial number. And at this point it's a collection of parts. And then moves on through. So what we have going on here is a laser cutter. We've got 4 of these machines, and we cut anywhere between 3/8 of an inch down to 22 gauge steel. And this particular machine is one of the faster types of machines that's out there. I think it cuts 500-600 inches a minute on a intermediate gauge material. But super fast, super critical what we do, because we control our own part cutting. We can change our designs all the time. It allows us to be real efficient with the amount of handling between the piece part and the production process. I almost want to say the parts never cool down. A part typically doesn't sit for more than a couple hours. They get cut, they go to bend, they get staged, they go to weld, they go through paint, assemble and on out. So it's all about throughput, in our space and with the amount of handling that we do. That's where it starts.
So what are we cutting right now?
That's the engine deck of a standard B. Yeah. Yep.
And that's 7 gauge steel. Somewhat lighter gauge. Right now. Okay. The technology of cutting sheet steel has come light years in about 10 years. It's ridiculously fast. Okay. We used to cut with plasma cutters to handle our plate steel.
Okay.
But the technology of cutting plate steel has just gone ridiculously far in the space of 10 years. For probably 15x, something like that, the speed of an old plasma cutter.
Oh wow.
This machine is maybe 2 years old. It was one of the first machines here in the United States that was 10 kilowatt. So lots of power. We're one of the earlier adopters. We really bought into that speed, and it has played out really well. The other 2 lasers beside it, well, this one being about 2 years old, is 4 times as fast as those other machines. So almost for the same price, the guys who make these lasers, each new iteration of making a new machine is getting better and better. It's not just speed, it's actually the simplicity of the machine. The older machines had probably double or triple the number of parts making up the machine. Part of that was the new ones are fiber, so that light just goes through a light beam of fiber. And you see that cutting has to whip around and things like that. So that light actually goes through that fiber optic cable, full 10 kilowatt of it, down to the cutting head. The older style lasers, where you have a beam going through something like that big through baffles, and the baffles had all these mirrors. So you can imagine something's creating the light back in the resonator. It's got to go through this whole baffling system while the cutting head is moving around, and it's keeping all this mirror light, and then it condenses it in the cutting head like that. And so basically it limited your cutting head's movement speed because you had all this complexity to it. So anyways, neat technology. It's come a long way.
Check that over here.
Yeah, this shows you where it's cutting as it's cutting.
Okay.
Pretty fast. Cutting it like butter.
Man, that's pretty neat.
The other machine is running.
Oh,
Let's see if another one is on.
It's kind of neat how it almost it's not often that some type of new machine or product obsoletes the other things before they wear out.
Gotcha.
But this is one of those technologies that it costs more to run old equipment in some cases than just getting the new one because of how good it is. This one just got commissioned a few days ago, so it's brand new. That's 10 kilowatt. This is 12 kilowatt, so it's 20% more power.
Okay.
Helps with those heavier gauges, have enough power to cut through it fast. Yeah. So far we've been feeding it the thick steel. Mostly we've been doing it the last couple days since it started running.
That's quarter inch.
What's that?
That's quarter inch.
Okay.
So it's cutting out a height selector, which is a bunch of little tiny back-to-back holes and quarter-inch plate. It's cutting out the gear teeth now. Yeah, this one just came online last week, I think it was. It's about $1 million at work.
What's that?
It's about $1 million at work.
You hear this guy?
This whole zone back around right here That's all of our tube cutting operation. So it could be tube, it could be flat bar, all the small things. So we got band saws and nippers and iron workers, that kind of thing. That's what's back there. Then we're gonna go check out the press brakes. So after all this plate steel is cut into all those shapes, the parts get delivered to these 4 press brakes down here. Parts are separated out from those lasers into different carts that are going to get fed to these different press brakes, depending on which part and which press brake set up to do it. The bend into a part. These machines have come a long way as well. It's like it actually calculates as it's doing the press motion. It knows when it's touched the metal, and it can sense how much resistance it has, because steel has some variance, depending on which way the grain might be, and plus or minus like 3% thickness from the mill. So what's cool is these new machines actually are smart machines. They sense what's happening, so it really does save the operators a lot of time achieving that perfect bend angle. As a matter of fact, you can feed it parameters, so you're bending a couple pieces and you tell it that it's a little wide, then it will start auto-correcting for the work you're doing or the run that you're running. Back in the old days, it would be, you might be within pretty good, and then you got to hammer the part to get it, just right.
Yeah.
A lot of labor savings there. This area, the shopping center. So basically, you got to get all the metal cut and bent first, and then after that, we've got to kit it up. So when at this point in the process is where all these parts that are in the shopping center on the shelves, we put it into a kit and one part to go through weld. We have a couple different main lines in Weld Line, so depending on which product it is, it's going to go down that weld line. But we pre-prep it into a kit. Makes it really fast for the guys in the weld line.
Yeah.
We measure our arc on time in the weld department, so how long are we actually, that's the value add, right? When I have my mask down and I've got my arc on, that's when we're making value. So we like to make sure our welders have the parts presented to them where they can grab them really quick, get to work, put them right back on that cart. That's what's happening right here. It's just putting it into a kit. It does mean there's a little bit more work on the front end. We got like 2 people on this side making those kits, but also translates to quality too, because these guys, they have to just worry about making sure the kit is correct. When it gets down there, so long as they get the right parts, it limits the amount of things they have to think about as well. They just grab the parts that are available on the cart, and if you put them together, you're going to have everything correct. Yeah.
So this is the main mower weld line where we mostly weld like the frames and brackets and that kind of thing. There's a couple different weld lines that make different parts, but at the beginning of the line it's a bunch of parts on the cart, and by the time it gets to the end, all the pieces are together and good to go. And then they come out the other end by paint. We'll walk by paint here in a second.
Okay, let's check out these parts.
Yep. So these are parts of the bumper, caster housings, pivots for the control handle. There's the bumper, fenders, some frame parts down there. Much the same thing on the back side.
Got it.
You can take a peek, that's the deck line, so 90% of our decks go all the way down through there.
Okay.
Yep. This line on our right side, it's a dedicated line for our smallest mowers, the B line. So that's what's happening right there.
Okay.
The B line.
So We're now at where we load the paint line, and this is the beginning of where production is sequenced according to time. On the weld side, they're working to match a buffer to set their pace. But here with the clock on the screen there, they're using this information to signal the rate at which they feed the assembly department. There's a couple assembly lines down there, and so they're loading it in sequence to match what the different lines are. It'll be in the paint system for about 2.5 or 3 hours. It goes through this wash system, goes through a pass to dry off the parts. Powder ovens on the other side of the wall there, comes through down to the assembly department.
So this is one of those parts you were talking about earlier?
Yep. So that's a ZXT. All the parts are welded up. That's the seat pan, caster frame, idler arms, the seat tray, baffles, deck lift shafts. The deck comes from a separate flow. You can see the decks feeding in on the other side over here.
Oh, okay.
Yeah. All right, we're going to take kind of a long trek around down to where the assembly department is. Paint first, or just go through assembly? Then the code, have to watch it. Huh? So what we have here is the assembly department. We've got 3 main assembly lines. We have one back there that makes what we call our standard Bs. We've got our middle line here, which makes all of our kind of intermediate size machines that have typically pump and motor drive systems with a single gas tank. And then on the far corner down there is the line that feeds in all our mowers with 2 tanks, bigger machines, ZKs, riders, those types of machines flow through there. And then there's a number of feeder work areas. For example, right here is where we build the decks. Back there we build the engines, we prep those and feed them into these 2 lines.
Okay.
Walk down this way.
Okay.
All right, we're where the action is now. So we're where the line that makes the bigger machines is. We've got a rider there. We got a ZXT here. We got a ZK. So you can see we're doing mixed model production. We don't make the same mower all day one day and then a different mower the next day, because what happens is one department will be really busy with one mower and another department won't be, and so you get all this fluctuation of work. When we do mixed model production, the digestion rate is much more smooth, even between 2 workstations. One mower might take 2 or 3 minutes longer than another machine, and so if you do one that takes more work and less work, every other machine cancels out, so then you're on pace. So every step of the process is choreographed, with a certain amount of time, the different things. We don't want anybody to rush.
Right.
But it's all about that steady pace of work. It's where you kind of get your efficiency and everything's sequenced in a particular way. But yeah, this is the main line for the big units.
So what we got over here?
That's a deck that's going to feed in to pair up with the ZK.
Okay.
This is kind of what we call the integration station. So right here is where the tractor body comes in, the deck comes along, and the upright comes along. So you're taking all these large pieces of metal, putting them together right here, and it starts looking like a mower after that.
Gotcha.
So these are sub-assemblies. We're making the deck somewhere else, we're making the upright somewhere else, we're making the engine somewhere else, putting the muffler and everything on it, and then it all comes together.
Carting them all here and then putting it together. Okay. And what we got right here, what did you say this was, the ZX?
I called it a ZXT earlier, but it's actually a ZK. They've got the same style wheel motors.
Okay.
But this ZK frame will match up with that ZK engine deck, with that 52-inch deck, and then there's an upright behind there that also go on, so it really becomes a unit right at this station.
Okay. So what's he doing over here right now?
So behind there we've got a rider who's routing the fuel lines. We put a lot of the fuel lines and wires and things in first because they're easier to get to before we put on the seat tray. But yeah, this is an example. We've got a rider right after a stand-on mower. We'll walk around to where the run-in station is. So right here, you can see that machine is sitting on that table. That table is a perfectly flat table. We set the air pressure, we set it there, we set the deck pitch, so we get that, you know, perfect rake on the deck. And then we bring it into the run-in station here, and this run-in station puts a load on the wheels, so lets us check that the governor's picking up, that the hydro system's, you know, running the right speed, the right power. We set the tracking so it drives in a straight line. Also, we put under load, it helps us find if there's any leaks or anything like that in the system. So we do that run in here. We burnish the clutch, we inspect a bunch of items, and then from here, it goes across the aisle, straight into crating.
Now, what do you do on the deck pitch? What's your standard as far as pitching the deck?
We have a standard that's, we call it a 1/4 inch, but it actually varies by the length of your blade. So if you've got a short blade mower, you actually maybe make it closer to 3/16. I don't, off the top of my head, know what the standard is that we use, but it's nominally a 1/4 inch pitch for a middle-sized mower. Yeah. And then left to right, I think our production requirement is 1/16. It can't be off more than a 1/16 of an inch left to right. It's pretty close, yeah. We wanted to get as accurate as we can because there's always going to be some settling and some stuff that happens after it leaves here, so the more accurate it is up front, the better.
Yeah, sure. Over here.
So over here, this is where we might, if there's like, let's say there was a part with scratched paint on it that somebody found halfway through the process, we're going to finish the mower and we might swap that item out. We also do some quality audits, those types of things in this area. But typically the mowers go straight through into the crating area. We'll head back there. So they get sequenced in. We've got a ZK and then a walk behind. And right here is where the mowers we call berths. So this is where the machine and our computer systems becomes an actual mower. It turns into from a collection of parts into a finished part number, and we record a bunch of information against that mower. You know, when it was built, all the components that go into it. That kind of begins the life cycle of the machine. That serial number lives with that machine. You know, everything is tied to that number. Even, by the way, if someone ever has a stolen mower, we want to know that, because what we can do, our service department can flag in our system as stolen, and we have a lot of techniques and some sleuthing with the amount of data that we have, where if we get a ping on that, we can let the original owner know, hey, we found some information. You know, we're not out there to chase mowers around, but what we're trying to do is make sure the original mower owner has whatever information that we have if that mower gets stolen. But the serial number process begins right here.
Now what behind is this?
This is a 61 WVLC. So we've got, in this series of walk behinds, we have 36, 48, 52, and 61 inch decks. And so it's the full range. It's the same tractor unit on all the different sizes, but what we do here is this assembly bolts on in different configurations, whether it's making the wheels wider or wheels front to back. So we make a 61 inch. The whole tractor is actually mounted further back, which gives us more leverage on the handlebars for the bigger deck, and brings the weight back a little bit as well. About 80% of our mowers, or maybe a little less than that, go into metal crates. All the 3-bladed mowers go into metal returnable crates, and then the little machines tend to go in wood crates.
Okay.
And it varies a little bit. When we export mowers, they get special crating as well. But all that comes together right here. So you were asking about engines. We've got a couple engines right here. Engines really are, right now, I think the base constraint in our industry. The amount of engines that the 4 major engine manufacturers can produce is setting the pace of production right now. And so we're all pretty short on engines, hand to mouth with a lot of engine models, try to keep things turning. And how long does this last? That's hard to tell, but I think we're definitely going to see for 2 years probably where, you know, inventories and what's on dealer showroom floors and stuff doesn't kind of get fully back to normal, because mostly of some of these major components.
So what you're saying is you need to get at least 2 or 3 Wright mowers just in case.
That's right. Well, having a backup mower is really important. You know, and if you've been doing it for a while, what you want to do is that older machine that it's got a lot of hours on it, but it's still running. Right. Only a little bit life left in it. Keep that mower on the side as your backup machine, so you're not always, you know, dependent on only your primary mower. Keep that turn and that reserve going. Now, if your old mowers, you just let them sit and rot, you don't get that advantage, and then you're stuck one day where now you have nothing running and you're trying to figure out which one's easiest to get running. But this spring's going to be rough because already shops are backed up. Already there's a lot of parts that are back order that don't exist anywhere in the world, can't be obtained. And new equipment is out there, but like what we're mostly seeing right now is, for example, if somebody wants 10 of the exact same model, it's hard to pull that together because there isn't enough inventory to tap.
So basically get whatever you can find right now.
Yeah, and it's not going to free up for a while. Yeah.
So a lot of you guys know my story. For some of you guys that don't know my story, last year both mowers went down. I mean, they were within, let's see, I think both mowers were under 1,000 hours, so you would think that I was good to go and I wouldn't have any problems, but hey, things come up, your mowers go down, 2 mowers down at the same time, and that's how I kind of got connected with the whole Wright Mowers, because a dealer 2.5 hours away from me contacted me. I've never met the guy, I've never talked to the guy, but he's been following me on social media, and I guess watching the channel. He saw what was going on. He said, hey man, come up to St. Louis and come to St. Louis Equipment, pick up the Wright ZK and try it out until your mowers get back up and running. So that's how I got connected with the Wright Mowers. That's how I tried them out for the first time. And I thought it'd be cool to come out here and talk to Ed, talk to Jeremiah, and see what they have going on here. And you know, just like he's saying, man, equipment is gonna be hard to find, mowers are gonna go down, you gotta have a backup. And I'm thinking, this is just how I'm thinking, but I'm thinking you gotta have a backup of the backup, because you always gonna have problems, you know, and you can't have any downtime. As you guys know that are running the lawn care business, man, lower profit margins, you gotta be as efficient as possible. And if you have equipment, you have to have it out there running. So think about that. Buy a Wright ZK, buy 2 or 3 of them, just whatever you can find. And just, you know, seriously though, think about that this season, because Ed is spot on saying, you know, with the engines, the mowers, you're just gonna have to take whatever you can find right now. And hopefully it won't last long, but until it does, man, we gotta stay ahead of the game.
So the question of how has Briggs really come on the market bigger in the past couple years, you have to roll the clock back quite a ways. So you go way back in Briggs, you know, they were on all the consumer equipment. Solid American brand on consumer equipment. Somewhere, I think it was around the late 90s, they created a joint venture with Daihatsu to spec and build these heavier commercial engines, and they called them Vanguard engines that came out of that operation. And so I think it was the Japanese designed engines built in Japan and brought into the US, and those are the Vanguards that we more or less know today, especially the big block Vanguard and the small block Vanguard. The 810cc Vanguard engine, that engine was actually designed in the US. But this was probably, I'm going to guess, 7 years ago or so. I guess there was the question of what was to be reinvested, the Daihatsu plant, tooling, machinery, and that kind of thing. And Briggs decided to make that reinvestment back in the US. So down in Auburn, Alabama, they started producing most of their bigger Vanguard engines and designing some new versions of it. So they brought on the EFI changes. So that 40 horsepower, 37 horsepower engine that we see on tons of equipment today, that engine block is a Japanese design that goes way, way, way back. It's just that it's really, really tried and true, had good cooling, and now they have, you know, all these newer housing, newer fuel injection system on it and that kind of thing. And it's really one of the better big block high power engines. Every engine manufacturer has their niche. I think Kawasaki's probably stronger when you look at your middle range horsepower engines. They've serviced that engine for many years very well, and they've staked their claim on a certain part of the market as well. But that Vanguard Daihatsu thing, I think, is really the backdrop that leads us to where we are today. Okay. Let me run by the paint booth, show you what that looks like. Let's go around the other side.
Okay.
So this is the paint process. The parts they're pre-treated. You can actually tell there's slightly like an orangey color almost. So they've been pre-treated as they come through here. And this eye is detecting where the parts are. We touch up the face of the parts, it goes through the automatic guns, and then we touch up the back side of the parts. And it's almost like more of a quality control on the other side of it. This system lets us, we have one paint system. This system lets us do quick changeovers. So we'll switch to black about 2 or 3 times a day. We're mostly running the orange, and the overspray gets recycled back into the guns again, so it's a very efficient system. A color changeover takes, I think last I heard was around 12 minutes or something like that. Okay. The assembly department has different breaks during the day. The paint system runs on a different break schedule so that they can, you know, some people go on break, other ones will come on, but we'll keep the paint running across those periods of time. So we buy a number of 15 or 30 minute time segments throughout the day of the paint system, which helps the black part color changeover process. Okay.
Oh, okay. So what's going on beforehand?
So the paint doesn't like to get into corners because it's electrostatically applied. They call it a Faraday cage. So the metal is grounded, the gun has positively charged paint. You know, it's like 100 kilovolt. So it's trying to stick up there on static electricity. It hates corners. So what she's doing is she's getting in a lot of the corners where the other guns are not going to fill it as well. And then on the end of it, the other person's more quality control checking the back side of the part for any other corners or edges that refuse paint. Some, if it's like panel or something, they won't even hit it. The automatic guns will take care of the whole part.
Oh, okay.
Just depends on the item.
You say you collect the paint and then...
Yep. Really? So all the overspray goes into a gap in the floor there. It goes back in the grinder and feeds back into the guns again. There's always a little waste. There's really, really fine powder that can't get used. And so probably once a month there's a couple 100 pounds of paint that we can't use. So this is what we call line A, which is where we assemble all of our accessories, service parts assemblies, those types of things. There are certain parts for mowers that we built 20 years ago that we only sell 2 or 3 of them a year. And so when they're needed, we actually build them from scratch and they come right through this department. When there's a machine down situation, oftentimes we can get a part through in about 2 days delivered. from raw material. Now the bulk of items are built pre-season. They go into warehouses, you know, staged to roll out in the spring. But this department here builds the kits, builds the Velkies, the gobblers, the bagging systems, all the kitted service parts. So this product is really part of what brought us into this business. This and the grass catcher. So my parents started cutting grass in the early 80s, and part of becoming more productive was, it was all walk-behind mowers at the time.
Right.
And part of the productivity was getting on a Velky that you could ride behind it. So you didn't have the fatigue, you could make up a little bit of better ground speed. And products changed a little bit, but you know, for the most part, it's the same thing. We started building around 1985, 86. And that was our original product that got us to manufacturing. Now over the years, we were software, building, scheduling, routing software. The accessories and the mowers came on in the mid-90s, and we focused really just on the mowers around that point in time. We moved up here around year 2000.
Look at all this, wow.
So when you have massive global shortages of components, you end up building stuff with one missing piece.
Oh yeah.
And then when the piece comes in, you install it and check it, and then you ship it out. But we've got a handful of mowers out here today. It's improved a lot. We're really wrapping up a lot of it. But at one point, I think we had almost 600 mowers out here, something like that. Which is not, it's not how we normally do this.
How many do you have out here now, you think?
This is probably a little less than half that.
Oh, okay.
Yeah. But usually what we build goes straight out within a couple days to our distributors' warehouses. But that's the world we live in. It's the struggle we deal with.
So now we're just sitting, huh?
Yep.
Waiting on parts.
Waiting on parts.
Wow.
And it could be anything. Stuff with bearings are hard to get. Electrical components are hard to get. Anything where there's like single source, you know, there's this one company that stamps this one part or something like that, and you can get blindsided by some of that.
Yeah.
But working through it.
So what's the process when you start getting the parts in?
For something like this? Well, first is the decision whether we build or not. So we're not going to build it if it's critical to quality, or you have to dig down past things, or you have to do a lot of run-in or testing of the machine. But something that can really just be dropped right on the machine pretty easily, you know, a cap of some sort or something like that, then we'll go ahead and build ahead. When the parts come in, we mark them for hold, and then also in our computer system they're on hold, they can't be shipped against. And then once we get them done and completed, then we update those and move it into shipping.
So what you're saying?
So we were just walking by this machine. He was asking what it is. This was a really popular machine a number of years ago, and it's called our standard RH. And it was, we were originally just making fixed deck mowers, and we wanted something with a deck that could go up and down while still being really compact. And I was at the time studying engineering in college, and so I did most of the design work on this one summer. But it's unique. It's got these, you know, real wide flat tires on it, real smaller tires, so it's really compact. And where this machine shines is if you got a couple thousand square foot lawn and you want to get in there, you know, around everything, so you have the least amount of trimming. This was kind of really popular, and it was in that period of time where walk behinds really have declined a lot. But right early days when that started happening, where people are moving away from you know, your pistol grip walk behinds into your stand-ons. But so he lets us sit here on it. So originally it was just a 36-inch deck, and then it kind of evolved over time. But it's unique in that you see how even the handlebar goes up and down with it. This wasn't really a floating deck. You could just change it, and then it would lock in, and it wouldn't be able to move from there. So it was kind of like, gave you that, we called them the rapid height, but let you change the deck height quickly without all the sophistication of a floating deck.
That is crazy.
But yeah, we built tons of these things, and there's still a number of them out there running.
They've given up on the little Stinger seat there.
Yeah.
But the whole group of those mowers, there was a couple different models, but they were all of the Centaur grouping. You can see right there.
Oh, okay.
Centaur is the Spanish word for to sit, verb to sit.
Oh, wow. So that's the name of the model.
Making standard mowers, we started making a sitting version of it with the little Stinger out the back.
Wow.
It was less than about 2% of our business these seats, and at some point it was one of those things where it was impossible to keep it in stock at a dealer, you know, for how often they sold. So we eventually got rid of them. We don't sell them that way anymore.
Now, what year is this one, you think?
Yeah, probably 2005.
2005?
Something like that.
So Ed was engineering mowers, and I was cutting grass as a teenager. So these Centaur mowers, I had a chance, the lawn company I worked for had standers, these things. They also had Exmark lasers. The crews always wanted to run the standards, but my favorite was these sit-down ones, because there's kind of these little tricks you can do with it. So you got that seat out the back, so you can put your weight down on the seat and get a wheelie going a little easier. When you're on a hill, you can also get your weight on a stand-on mower. You just can't do what you can do. You can bring your weight so far back. If you're on that really steep hill, you get seated way back here, and you'll have more traction on a hill than almost just about any other mower, just simply for the fact that you could get your weight way back here to prevent the front from wanting to go down. So I really enjoyed these mowers.
That is cool.
A little piece of history.
So at the GIE, I rode a standard that had that little seat. What was that?
Wasn't bad this year though, right?
2018, I think.
Yeah.
What was that?
That was probably, we call them Sport X, the Standard X with the seat on it.
You don't have that now?
No, we don't make them.
We had a transition from calling those little seated things Centaurs, which were their own grouping of things. And then there was an interim period, probably 2015.
Well, originally they were all Centaurs, then we called them Sports and the Sport RH, and then we called them, like, then we had the Sport X and the Sport Intensity, and so originally the Centaur,
calling them sports. It would be a sport version of a Standard X. So it was basically the same frame and everything, except for adding a seat and making the upright a little bit shorter. So it's more in that mid-range between you could stand up and sit down with it. Ultimately, why don't we do it anymore? Well, it's kind of like you're trying to mash two things together, and so you end up with a little bit of a suboptimal result. So if your upright's right there in the middle, it's kind of not optimal for standing, and it's not completely optimal for sitting either.
The other thing is that Germany exclusively bought mowers with seats on the back. 100% of what they bought. And for other reasons, we ended up discontinuing our business in Europe. And so without that piece of it was kind of another reason why the US part of the business was so small for the seats that we eventually dropped it. They make them. I mean, we have all the service parts.
All right, guys, we are done here at Wright, touring everything. We got Ed over here, Jeremiah over here. I appreciate it, guys. We'll do the bump.
It was a lot of fun.
Appreciate you coming by.
Yeah, thanks a lot for allowing me to come by and check all this out.
Doors are always open.
I appreciate it. All right, guys, I appreciate you watching the video. I hope you enjoyed the content. Like I said before, if you do like the content and you want to subscribe and be notified of future videos, be sure to hit that subscribe button, hit the bell so you'll be notified of all the upcoming videos. But thanks again for watching. I'm Cameron with the Lawn Care Life in Missouri. Hope you guys are having a good day, man. And as always, hey, God provides.